Hello, dear students. The topic for today is factor theorem. Now, you remember doing long division in arithmetic. So, if you have a case of 7 divided by 2, you will get the quotient as 3 and the remainder as 1. By division algorithm, 7 can be written as 2 into 3 plus 1. In this case, can you call 2 a factor of 7? Or can you call 7 a multiple of 2? Clearly not, because 2 does not completely divide 7, and that is evident through this remainder 1. For 2 to become a factor of 7, this remainder should be 0. We can extend the division algorithm to polynomials also. So if we have a polynomial in x as fx, and if it is divided by dx, let the quotient obtained be qx and the remainder be rx. All these four polynomials can be related to each other and can be written with the help of some mathematical operations with the help of the division algorithm. So f of x is equals to d of x into q of x plus r of x. Now, let us consider a special case when this r of x happens to be 0. What if the remainder comes out to be 0 on dividing a polynomial px by another polynomial x minus a? In that case, x minus a is called the factor of the polynomial. Now, how do you take out the remainder while dividing a polynomial by another polynomial? We have the remainder theorem already with us. So let us now see an extension of that. Factor theorem states that if p of x is a polynomial of degree n greater than equals to 1 and a is any real number, then x minus a is a factor of px if p of a is equals to 0 and p of a is equals to 0 if x minus a is a factor of px. Both of them are converses of each other and essentially imply the same thing. Check whether x plus 2 is a factor of this polynomial. In this question, we need not actually apply long division on both these polynomials. We can simply take out the remainder obtained on dividing both these polynomials by the remainder theorem. How do you take out the remainder? You first will take out the 0 of this polynomial by equating it to 0. When we find out the 0, that happens to be minus 2. Let us substitute that minus 2 in this given polynomial and find the value of p of x at minus 2. When you solve this, you get p of minus 2 equals to 0. This means the remainder is 0, so x plus 2 is a factor of the given polynomial. Let us consider a similar example. Let's work out one more. Examine whether x plus 2 is a factor of x cubed plus 3x squared plus 5x plus 6. Again, in this question, you need not do long division. You can easily find out whether it is a factor or not by first taking out the remainder. Let's first take out the 0 of this polynomial. So 0 of x plus 2 is minus 2. How do you take out the 0 of a given polynomial? You remember clearly that you equate the given polynomial to 0. Now, let us substitute this minus 2 in the given polynomial. You get something like this. P of x was x cubed plus 3x squared plus 5x plus 6. You substitute x as minus 2 because you need to take out the value of this polynomial at minus 2, which was the 0 of the divisor. On solving, you open the brackets very carefully. Minus 2 cube is minus 8 plus 3 was getting multiplied with the square of minus 2, which happens to be 4. 5 multiplied by minus 2, that is minus 10, and so on. You get the remainder as 0. So by factor theorem, x plus 2 is a factor of the given polynomial.